Hello and welcome back to HGT STEM. I'm Ava Grace and today we're going to be looking at helium. So, without further ado, let's get to it.
There are 115 more videos to watch. In fact, there are 117 more videos to watch.
Was that different? Helium is the second element on the periodic table. It makes up 35% of our universe.
That's a big part of our universe. 35% just helium.
But it's very rare here on the planet Earth. In fact, it's the only element in the periodic table that was first discovered outside our planet. The first
That's really cool. It's the first element on the periodic table that was discovered somewhere other than Earth.
indications of its existence came when people were looking at the spectrum of the sun during an eclipse in 1868, the year before Mendeleev proposed the periodic table, and they noticed a single very bright yellow line. The yellow line is due to the electrons of the helium atom being excited. You can do the same thing here on Earth. In fact, Neil has his own helium star. This is a glass star filled with helium gas. And if you apply very high voltage, you can excite the electrons in the helium and it emits light. And then with a small...
That's really cool. If you get enough energy into the helium, it gets excited and lights up.
spectroscope, you can look at it and see the very yellow line that was detected in the sun spectrum. To begin with, they thought it was sodium, but then they realized it must be a new element, and because it was found on the sun, it was given the name helium from the Greek word helios, which is, I believe, what the sun is called in Greek, or the god of the sun is called. It was then discovered on Earth at the beginning of the 20th century, when people were examining a uranium mineral called, I think, cleveite. Then, a few years later, fairly rapidly, helium gas was discovered as a component of natural gas coming out of gas fields in the United States. The reason why you find helium associated with uranium, and in fact other radioactive materials, is because the nucleus of helium contains 2 neutrons and 2 protons, and the naked nucleus of helium is what are called alpha particles that are emitted during radioactive decay. So if a radioactive atom decays and emits an alpha particle underground...
That's really cool. So, the radioactive atom decays and emits an alpha particle, and then it becomes helium.
Decays and emits an alpha particle underground. The alpha particle quickly picks up a couple of electrons and becomes an atom of helium. And over millions of years, this can accumulate in gas fields. As far as I'm aware, all of the helium in the world has come from radioactive decay, apart from a small amount that has come from people letting off hydrogen bombs.
That's really cool. Almost all of the helium that we have here on Earth came from radioactive decay. Kind of crazy to think that we inhale that to make our voices sound funny.
The width of the fireball at this time, about 3 seconds after detonation, was 4 miles.
Helium in the natural gas was discovered fairly shortly before the First World War, and so it was quickly realized that this gas could be useful for observation balloons on the Western Front, on the battlefields.
The enemy's troop movements and defense schemes are under constant observation by French and British airmen, as well as by observation balloons.
Because unlike hydrogen, it doesn't burn. So if a bullet goes through your balloon, it doesn't immediately blow up. So helium started to be produced as a strategic material.
Non-explosive gas for dirigibles. America has a virtual monopoly of it, helium.
So there's a long history in the United States of legislation for conserving helium for strategic defense purposes.
The subject has, of course, attracted great attention all over the world because of the terrible Hindenburg disaster. The American President's Cabinet Committee is convinced that helium should now be made available to Germany for use in commercial airships.
So a helium nucleus, or helium atom, weighs 4 times as much as a hydrogen atom, which has just 1 proton. But because hydrogen exists as an H2 molecule, helium atom, which is the same as its molecule, weighs twice as much as a hydrogen molecule. And Neil, our colleague, has devised quite a nice little demonstration where he has a balloon of hydrogen and a balloon of helium of about the same size, and shows that the hydrogen balloon with a suitable pulley system can actually pull the helium balloon downwards, because there's a lot more lift in a hydrogen balloon than in a helium one, because the hydrogen is lighter. The most important property for helium nowadays is the fact that when you liquefy it, it forms the coldest liquid that one can obtain. Liquid helium boils at minus 269 degrees centigrade.
I thought that liquid nitrogen was the coldest material, but I guess not. Liquid helium is... I don't know if it's a lot cooler or just a little bit. Maybe he'll tell us.
That is 4 degrees above absolute zero. So you can use liquid helium to cool materials down. And particularly, you can cool certain alloys of metals which lose all their electrical resistance at low temperature, so-called superconductors, which can be used to build really powerful magnets, particularly for our university, for magnetic resonance imaging, for looking inside people's bodies to see that all is well. And you need a very high magnetic field.
They use liquid hydrogen to make MRI machines. That's really neat.
And so our university has a plant for liquefying helium. And Brady and I were able to go and visit it. We were shown how the liquid helium is filled into large thermos flasks, so-called Dewar flasks. When you want to pump the helium out, remarkably, you use the inside of a rugby football. This is the bladder inside it. A rugby football is quite similar to an American football, and by squeezing this, you can pressurize the helium and get it to come out. And if you do it wrong, it blows up to a large size, the bladder. And we were shown what happened. I was a bit frightened, it might go bang. We were then shown what happens when you squirt liquid helium into air. And it's really strange because as the liquid comes out, the jet of liquid looks very like a flame. The shape is almost the same, though of course it's whitish in colour. Neil had given us a small metal, stainless steel thermos can. It's very important it's stainless steel because helium can go through glass. So if you use a glass thermos, as soon as you put helium into it, it stops being a thermos vessel.
You can... Wait, so helium can go through glass. That's interesting.
Neil wanted us to try and see if we could fill this can with liquid helium so we could actually show you what the liquid looked like. We had a number of attempts, and the most spectacular eruptions of cold helium vapor. The problem is that helium vapor that comes off is so cold that it not only freezes all the water vapor in the air, so you get a fog, but it can also liquefy the oxygen or nitrogen in the air. So even though we pre-cooled the thermos with liquid nitrogen, so we started at a fairly low temperature, it was quite difficult to get the liquid in. And once we got it in, there was so much fog that it was quite difficult to tell whether we were really seeing the surface of the liquid or not. But it was great fun. Brady and I really enjoyed ourselves, and the technician, Sanjeev, was really helpful. He even tried filling a much bigger vessel with liquid helium and pouring it into our thermos. Usually when people use liquid helium seriously, for example for magnetic resonance imaging, because the gas is expensive, it is piped back to the liquefaction plant so it can be recycled. And you've all seen
It's really nice that you can recycle it, so that way it's not just getting wasted.
little helium balloons that people use at parties and the like. But at the liquefaction plant, they have an enormous yellow balloon which they use for storing the gas before it's liquefied. And they have gas meters to measure the volume of gas coming back so that they know how much gas has been lost and how much they have to charge each customer for the gas that they've lost. I used to work with liquid helium a long time ago, and I still have the very old gas meter that we used, which is just over there on the filing cabinet.
Now, real quick before we're done with this video, I want to show you something. We created a website, and it's called agtperiodictable.com. Here, wait, let me try that again. Here, and you can come here and look at all of the elements. They're color coded based on what color the element should be on the periodic table. And you can see hydrogen has all of the information, and here's helium that we just watched. So, with that being said, thanks for watching, and we'll see you next time. Bye!